Hello and welcome. In this lecture, in which we will discuss about the distribution function of a random variable. In particular, we will discuss about the distribution function of a discrete random variable. Okay, so in this lecture we will discuss about the distribution function of a discrete random variable. First we will try to understand what do we mean by the distribution function. After that we will take some examples so that we can have a clear understanding about how to calculate the distribution function once we are having the distribution of a discrete random variable. So, a distribution function, suppose let x be a discrete random variable. So, whenever we are having a discrete random variable, certainly we have the probability distribution. Okay, probability distribution, or we may have the PMF or the probability mass function of the this discrete random variable x. Okay, so we have this PMF, which is simply represented by fx, and the role of this fx or the PMF is to assign probability for each of the possible values of this discrete random variable. So, now the distribution function, okay, distribution function which is generally represented by capital Fx or big Fx, is provide you the probability, the total probability available at a certain value of x. Okay, so this provides you the total probability available up to a certain value of the some given value of this random variable. Means if you consider this x, which is a discrete random variable, and let's say it takes 0, 1, 2 and 3 values. Now, if you want to calculate the value of this distribution function at the x is equals to 1, so this will give you the sum, okay, sum of all the probability available till x is equals to 1. So, it will add all the probabilities available till x is equals to 1. So, this is how we can find the value of this distribution function at some given value of x. Now, there are certain properties keeping this in mind. So, we are having the properties of this distribution function. So, the first one is that f of minus infinity is 0 while f of infinity is 1. So, because it adds all the probability available till the point, so minus infinity is the point from where we begin. So, there is no probability available before that. That is why this is 0, while at x is equals to infinity we completed all the possible values of the random variable, and this will provide you the value 1 because it had all the possible values of the random variable x. Now, the second important property is that this f x, which is our distribution function, is is a monotonic function. Okay, is a monotonic function. In fact, monotonically non decreasing function. Okay, it this value of this function always increases, it never decreases. Okay, so this is how, or what do we mean by this distribution function, and these are certain properties of the distribution function. So now in order to get a clear understanding of this distribution function, let us discuss this problem, which is based on this discrete random variable whose PMF is given to us, and it is also given that the value of this PMF is 0 except the points x is equals to 0, 1 and 2, and so the non-zero values of this probability mass function at these points are also given to us, but it is not exactly numerical value. It involves an unknown, which is a here. So let us first makes the distribution of this random variable or the discrete random variable. So here what we are having, we are given the values of this x, which are 0, 1 and 2, and also we are given the probability. Okay, so the probability is 3a cube, and it is 4a minus 10a square, while it is 5a minus 1 for x is equals to 2. So first of all, we have to determine the value of the unknown a, and for which we use the same property, which is summation px is 1, which implies that you will have 3a cube plus 4a minus 10a square plus 5a minus 1 is equals to 1. So we are using this property that when you add all the probabilities available to the given values of a discrete random variable, so the sum should be 1. So this gives you a cubic equation in terms of a, which is 3a cube minus 10a square plus 9a minus 2 is equals to 0. So this 1 will be transferred towards the left hand side, and you will get minus 2. So this you can easily factorize as a minus 1. This is a cubic equation, so it has 3 linear factors. So that is a minus 1, a minus 2, and we have 3a minus 1 is equals to 0. So now when you add this, when you simplify this, so you will get the values of a as 1, 2 and 1 by 3. Now out of these 3 values, we have to select only one value which is appropriate and which satisfies the condition of probability. So in order to check this, if suppose we consider a is equals to 1, then the probability of x is equals to 0 is 3a cube. Okay, it is given to us that probability of x corresponding to x is equals to 0 is 3a cube. Okay, so you will obtain p0 is equals to 3a cube. Now if you put a is equals to 1, so this is coming out 3, and which is not possible, because the maximum possible value of the probability is 1. So this 3 is not possible. Similarly, if you consider a is equals to 2, then you have this p0 as 3a cube, which is coming out as 24. Again, it is not possible. So the only possible choice which we are left with is, so therefore we can consider a is equals to 1 by 3. So using this a is equals to 1 by 3, we obtained the distribution of this random variable as, so again we make this distribution. Now this time we have the numerical value of all the probabilities corresponding to each and every value of this random variable x. So the probability will be coming out 1 by 9. So it is probability of x. So it is 1 by 9, 2 by 9, and finally we left with 6 by 9. So in this way, now we are having the distribution of probability distribution of this discrete random variable. Fine. Now in order to obtain the distribution function, so our next part is distribution function. Okay, so we have to determine the distribution function. As you can see in this problem, that we have to solve two parts. First one is to find out the value of a, and the second one is the distribution function. So distribution function fx, you can write it as, so when this x is less than 0, so of course the value is 0, because there is no point available less than 0 which is having non-zero value of the probability. Now when you consider the interval 0, x is greater than equals to 0 and less than 1, so you can see that, because in this interval you can easily identify that 0 is included but 1 is not included. So we have to add all the probabilities. So because this is it is given that the value of the probability except these 3 points is 0, so there is no probability. However, because 0 is included here, so we have to add only this probability, which corresponds to x is equals to 0. Now the next is x greater than equals to 1 less than 2. So for this you can see that we have to add all the probabilities available till 2, where 2 is not included here. So when you are in this interval, you already covered this x is equals to 0. So the value of this distribution function is 1 by 9 plus 2 by 9, because when you move in on real line, if you move up to this 1, then you already, because you started moving from this suppose from minus infinity, so you already when you are started moving from minus infinity, you already covered this 0 in order to reach this 1. So you have to add this the probability corresponding to x is equals to 0 and the probability corresponding to x is equals to 1. So that is what we have done here, and we are having 1 by 9 plus 2 by 9. Now for x greater than equals to 2, so because when you move 2 onwards including this 2, so we have to add all the probabilities available till 2 onwards. So in order to obtain this, we have to add the probability corresponding to x is equals to 0, x is equals to 1 and x is equals to 2, which is certainly 1, because that this is the sum of the total probability available corresponding to this discrete random variable. So this is how we can obtain our distribution function in this case. So it is a very simple procedure, and we can easily calculate the distribution function in this manner, we should keep in mind that whatever the point is given to us to find the value of this distribution function at that point, we have to add the probability available till that point. So that is why we are adding this. Okay, so you can also write this 1 as 1 by 9 plus 2 by 9 plus 6 by 9, because this is the total probability available from the point x is equals to 2 onwards. So this will coming out 1, which is written here. So this is how we can calculate the distribution function of a discrete random variable. Okay, so I hope that it clears your understanding of the distribution function. Thank you.